Hey, welcome back to the second part of the FDRANA WebApp explanation. Today, we'll explore more advanced steps together. We will now create the same file in Microsoft Excel using the same headers and then upload it to the Chief Consultant WebApp. Now, I'm handing over the explanation to John, who will walk you through how to create the Excel data and upload it into the Chief Consultant WebApp.
Thank you, Adam. Now, as you can see on the screen, there is an image of a sample 11 kV distribution feeder. Based on this sample, we map the single line diagram in Microsoft Excel by creating a structured data file. The Excel sheet contains the required column headers: FROMNODE, TONODE, KMTRS, code, prop code, and NODEKVA. We then enter the complete network data, covering all 10 line sections along with 5 distribution transformers. Once the data entry is completed, we save the Excel file. At this stage, our input data is successfully prepared and ready for upload. Next, we open a web browser and first navigate to www.google.com. From there, we open the official website www.chiefconsultantpack.com and wait until the website is fully loaded. From the software header menu, we select the drop-down option and choose the FDRANA tab. When the FDRANA page opens, we can see the key features of the FDRANA WebApp. At this point, we ensure that the Excel data we prepared fully complies with the technical requirements of the web application. After verification, we scroll down to the bottom of the page where we find the Login section. Here, we enter the correct passcode provided by the Chief Consultant. After entering the password, we click on the Login button and wait for the welcome screen to appear. Once logged in, we upload the Excel data file named Test Data in XLSX format. After uploading the file, we click on the option to generate the single line diagram. The system processes the data, and after a short wait, the single line diagram is displayed on the screen. As you can observe, the generated single line diagram shows the same nodal connectivity as the original sample diagram shown earlier. Moving forward, we can see several important features of the FDRANA WebApp. These include options to analyze a new file, download the Excel data, which is particularly useful when importing files from other sources, such as JSON or P objects, and access additional tools. 2 very important sections are also available: options to download DBF data, download a sample MEM file, download the single line diagram on A4-sized pages, download the diagram as a PNG file, print the diagram, and finally, log out of the web application.
That was trial, and now we show you the real hundreds node distribution data. Go, Adam.
Thank you again. Since real-world distribution feeders consist of thousands of nodes and hundreds of transformers, we now demonstrate the scalability and practical applicability of the FDRANA WebApp. To do this, we upload the data of a real distribution feeder into the web application using an Excel-based input file. For this purpose, we select the Upload File option and upload the process network data. After uploading the file, we wait for the web application to process the data and generate the single-line diagram of this complex feeder. Once the diagram is generated, we proceed to explore the features of the web app one by one. As you can see on your screen, the feeder contains hundreds of transformers with different capacity ratings. The node numbers are displayed at each node, and the transformer capacities are shown alongside the red triangular symbols, which represent distribution transformers. The single-line diagram clearly and cleanly illustrates the main feeder stem, along with all branches and sub-branches. The entire network data is well organized and visually presented in a structured manner. Now, let us explore the features of the web app. The first option is Download Excel Data. We click on this option and open the downloaded Excel file. Here, we can observe that approximately 230 nodes are present in this feeder. We verify the network connectivity by checking that the number of rows corresponds to one more than the number of nodes. This dataset represents the core input on which the feeder model has been constructed. Next, we move forward and explore the remaining features of the web app, namely Download DBF Data and Download Sample MEM. We download both files and then rename them as Demo6, ensuring that the file extensions remain unchanged. While renaming, it is critical to ensure that both files have exactly the same name, as these two files are required together for the FDRANA analysis software. After renaming, we cut both files and paste them into the ELR folder located in the C drive, where the FDRANA analysis software is installed. Once the files are placed in the correct directory, we proceed to run the DOSBox environment to initiate the analysis process.
Are we still together? Let's start the DOSBox show for FDRANA analysis.
When we open the DOSBox environment, we begin the analysis by selecting the High Tension Analysis option and pressing the Enter key. The analysis screen opens on the right-hand side. From the right side menu, we choose the option Use Existing File and press Enter. We then press any key to continue. At the prompt to enter the desired file name, we type Demo6 and press Enter. We press Enter once again to proceed. After retrieving the data, FDRANA loads the Excel-based network data into the system. This is where the real value of the process becomes evident. We verify that the data has been successfully merged into FDRANA by selecting Modify Segment Data. Here, we can confirm that all 231 rows have been correctly transferred into the software. This demonstrates that we did not need to manually enter the data segment by segment. Instead, the entire dataset was imported directly, eliminating the need for time-consuming data punching. Similarly, data from other power system software platforms such as SIME, ETAP, Power Factory, and other database-driven tools can be loaded using the same approach, allowing comprehensive 11 kV distribution feeder analysis within FDRANA. After verification, we press the Escape key to return to the main menu. From here, we scroll down and select the option Proceed for Analysis, and then press Enter. The software performs a network consistency check, and then opens the analysis parameter window. At this stage, we enter demonstration values to evaluate the performance of the imported Excel data. We input the feeder current as 300 amperes for the 11 kV feeder and press Enter. We keep the bus voltage at 11.0 kV and press Enter. Next, we set the power factor to 90% and the load factor to 60%, pressing Enter after each entry. For the Study with Growth option, we select N and press Enter. The software then begins processing the network data. Since the feeder consists of hundreds of nodes and transformers, the load flow analysis takes a reasonable amount of time, and we wait until the computation is completed. After the initial processing, the software prompts us with the option, Do you wish to install new capacitors? We select N and press Enter. If we had selected Y, the software would have guided us through capacitor placement on optimized nodes and re-performed the technical analysis. However, since we chose N, the capacitor selection process is skipped. Next, we are presented with options to Display Results and Print Results. We select Display Results. Here, we can view critical network information such as the allocated load, total feeder demand, and the connected kVA of the feeder. By scrolling down, we can review section-wise results, including current values, percentage loading, voltage drop, and kilowatt losses for each feeder segment. By pressing the S key, we can access the summary of the entire distribution feeder. The system summary displays key performance indicators such as line losses, transformation losses, total power losses, percentage power loss, annual energy loss, and other essential metrics. In this way, the FDRANA WebApp, combined with its analysis engine, enables accurate, efficient, and scalable analysis of real-world 11 kV distribution feeders.
Now you have seen the FDRANA processing. Let's explore the other features of WebApp.
Now, let us return to the browser and explore the other tab options available in the WebApp. When we click on Download SLD on A4 pages, a PDF file of the single line diagram is downloaded. This diagram is automatically split across multiple A4-sized pages, allowing us to examine the feeder layout more efficiently. These pages can also be printed directly on standard A4 paper for detailed review and documentation. Similarly, we have the option to download the single line diagram as a PNG image in full resolution, which is particularly useful for plotter printing and other large format requirements. Let us click on this option and view the result. As you can see, we can zoom in and inspect the complete feeder single line diagram in detail. This image can be used for plotter printing as well as for reporting and engineering documentation. In addition, the WebApp also provides an option for direct printing of the single line diagram. Now, let us move further down and explore one of the most interactive and practical aspects of the WebApp. In real-world engineering scenarios, feeders often need to be modified and reanalyzed to evaluate pre- and post-modification performance. To support this, the WebApp provides tools to install new transformers, redraw the single line diagram, and generate updated DBF and MEM files for FDRANA processing. Let us explore the Add Node feature of the WebApp. Suppose we need to connect a new 200 kVA transformer from node 16. We first enter the FROMNODE ID as 16. Since we are adding a new transformer, we must first create a new node. Before doing so, it is essential to ensure that the new node number does not conflict with any existing nodes. Let us create a new node with ID 231. Next, we define a span from the existing node to the new node. In this case, we add a span from node 16 to node 231 with a length of 50 meters. We then select the conductor type for this span. Let us assume the conductor is rabbit with the code RAB. We directly enter the transformer rating in the kVA field as 200 kVA and then click on the Add and Update button. A confirmation message appears stating, "Node added successfully. Diagram updated." On the single line diagram, we can now see that the new transformer has been added to the feeder. At this point, we can download the updated data files for FDRANA software as well as the updated single line diagram reflecting the modification. Moving forward, we explore another important feature of the WebApp, which is Update Conductor. This feature represents a practical engineering approach for assessing the impact of reconductoring. In many cases, it is necessary to upgrade the conductor of a feeder section and then analyze the resulting performance improvements. For example, let us consider the section from node 1 to node 2. We propose a new conductor type, such as Osprey, with the conductor code OSP. We enter the code OSP and then click on Update and Refresh. A confirmation message appears stating, updated line 1 to 2 to OSP. We then download the updated PNG diagram and zoom in to clearly verify that the conductor type has been successfully updated on the single line diagram. In this way, we explore both the Add New Transformer feature and the Update Conductor feature of the web app, demonstrating how the platform supports practical feeder modification and detailed engineering analysis.
Thank you very much for watching the complete demonstration of FDRANA WebApp. We have many more electrical web apps. Stay tuned with us and comment your suggestions.